Today we're going to learn some tips and tricks on how to write electron configurations. Now notice I have a chart with numbers written here in columns. Now if you learn how to write this chart out for yourself, you will never forget how to write electron configurations. The first column has the numbers 1 through 7. The second column has the numbers 2 through 7. The third column has the numbers 3 through 6. And the fourth column has the numbers 4 and 5. After writing out this series of numbers, all you need to do is label the orbitals on each column. The first column with the numbers 1 through 7, you label with an S. Each of the numbers, the 1, 2, 3, 4, 5, 6, and 7, have an S behind them. The second column, you put a P. And you put P's behind each and every one of the numbers in the second column. On the third column, you place a D. And on the fourth column, you place an F. The third thing you need to note is the number of electrons that each orbital can hold. The S orbital can hold up to 2 electrons. The P can hold 6, the D can hold 10, and F can hold 14. Now all that's left to do is form the diagonal pattern that exists in this chart. You start out with your 1s. You then make another diagonal line that only goes through the 2s. Then your line goes through 2p, 3s, 3p, 4s, and so on. If you can write out this chart for yourself and make these diagonal lines, you can write any electron configuration for any element. For example, if you were to write out the electron configuration for boron, whose atomic symbol is B, you would first need to check the periodic table and see what its atomic number is. And according to the periodic table, boron's atomic number is 5, meaning that boron has 5 electrons in its outer electron shell. That means that all we need to do is go through this chart and fill up each orbital until we reach the number 5. So we'll start with the 1s. 1s can hold 2 electrons. So we put 2 here. Next on our chart comes 2s. 2s can hold 2 as well because it has the letter S behind it. 2. So thus far we have 2 and 4 electrons. So we need 1 more electron, so we need to move to the next orbital shape. So after 2s comes 2p. So we write our 2p. Now 2p has a capacity for 6 electrons. However, boron's atomic number is 5. So all we need to do is put 1 electron in the 2p orbital. And that's it for boron's electron configuration. Now for a few examples. If we were to write the electron configuration for carbon, we would again have to check the periodic table. And according to the periodic table, carbon's atomic number is 6, meaning it has 6 electrons in its electron shell. So if we were to write for carbon, we'd fill up each orbital just like we did with boron until we get to 6. So we have 1s, and we fill that completely, which can hold 2. We have 2s, and we fill that completely, which also can hold 2. Then after 2s comes 2p. And thus far with carbon we have 2, and 2, which is 4 electrons. Our goal is to get to 6. So if we already have 4, although the p orbital can hold 6 electrons, all we need to do is put 2 in it in order to reach carbon's atomic number, which is 6. Now neon is a special case because neon is a noble gas. And we're going to learn later on in this lesson how noble gases are useful in writing a shorthand version of these electron configurations. Now if we are to write the electron configuration for neon, we need to reference our handy-dandy periodic table. And according to the periodic table, neon's atomic number is 10. So as with every other electron configuration, we start out with our 1s orbital and we fill it up. And S can hold up to 2 electrons. We then move on to the next one, which is 2s. And S can again hold 2 electrons. Then we move on to the next orbital, which is our 2p. And P can hold up to 6 electrons. Thus far we have 2 and 2, which is 4. So in order to get to 10, we're going to have to fill up our p orbital. So in this case, we have 2p, 6. Now that we know neon's electron configuration, it would be very simple to write out magnesium's electron configuration. We know that neon has an atomic number of 10, and we know that this is its electron configuration. Now, according to the periodic table, magnesium has an atomic number of 12, 2 more electrons than neon has. So instead of starting from scratch, we can start right where we left off with neon and just add on another orbital and put our 2 electrons on there. So we move on to the next orbital after 2p, which is 3s. And we place our 2 extra electrons right there. And now we have, instead of neon's electron configuration, we have the configuration for magnesium. Now we're going to learn about the shorter and even easier way to write out electron configurations. This is called noble gas notation. Now it's called noble gas notation because we actually use the names of noble gases to cut out writing out extra orbitals. Just as we did with the magnesium, where we just, instead of writing everything from scratch from neon, we just added on our 3s2. The same concept goes in with our noble gas notation. Now, helium has a notation of 1s2. So if you were to write the electron configuration for any element that's in the period after helium, such as lithium, beryllium, boron, carbon, etc., instead of writing out the 1s2 at the beginning, all you would really have to do is write out helium's atomic symbol in brackets. And then add on anything extra that needs to go after. So beryllium has an atomic number of 4, and helium's atomic number is 2. So you just need to add on 2 more electrons. The next electron orbital that comes after helium's, which is 1s2, is 2s. There are already 2 electrons in helium's notation, which is 1s2. So all you need to add after the helium is 2s2. Now if we wanted to write out the electron configuration for calcium, the noble gas that we would use for that is argon. Why would we use argon? Because argon is placed at the very end of the period that precedes where calcium is. So argon is in period number 3. Calcium is in period number 4. So whenever you're trying to figure out which noble gas you use, you look at the noble gas that's at the end of the period that comes right before the one that your element is on. So instead of writing out all of this, 1s2, 2s2, 2p6, 3s2, 3p6, when you're writing out calcium's electron configuration, you can actually skip all of that and simply put argon's atomic symbol, which is Ar, inside of brackets. You then can skip writing all of this and move on to the next orbital shape. So after our argon, which ends in 3p6, comes 4s. Now, argon's atomic number according to the periodic table is 18, and calcium's is 20. So you really just need 2 more electrons. And our s orbital holds exactly 2 more electrons. So all we do is add a 4s2, and you now have calcium's electron configuration. If you apply these simple principles that you've learned today to writing out electron configurations, you will never go wrong. See you next time.